Hello and welcome to the Kielder Observatory podcast. I'm Ian Brannan, and in this episode I'm joined by science communicators, astronomers at the Kielder Observatory, Ishbel and Ellie. And we have a special guest joining us very soon as well, Dr Victoria Fawcett, who is an observational astronomer, and she knows all sorts of things about galaxies and some research about quasars and whether these are a link in galaxy evolution. Of course, we have apparatus such as the James Webb Space Telescope, which is able to contribute to that knowledge, but we'll find out more about her research and why she was recently an award winner as well. More from Dr Victoria very soon. But first of all, let's start by having a look at what's been happening in the more recent past at Kielder Observatory with Ellie and Ishbel. And Kielder Observatory has been on the road a fair bit, bringing the observatory to you because of the snow and ice, which is one of the perils of having such a remote location up a 2-mile-long track in pretty much the middle of nowhere, and just outside the Kielder village, of course. So it's been inaccessible for a bit, but the telescopes have been on the move, and a few pop-up events have been happening around the northeast.
Yeah, definitely. When the observatory's closed, it's always clear. It's the way it works. Whenever we can't get to the observatory, it's always clear. So we stole one of the telescopes and we did pop-up events around the northeast. And we went to Kielder Castle, we went to Whitley Bay, we went into the centre of Newcastle even. And it was really lovely. It was lovely to see people.
And I was at that one at Whitley Bay, and it was a big turnout as well, and lots of people coming and going through the couple of hours that you were there. But what these serve to do is give people a real taster of what happens at the observatory, where people are able to make it to these maybe more local events, because, of course, getting to Kielder can be a little bit of a mission, but also just showing that there's plenty to be seen in the night sky as well. Wherever you are in the northeast, whether you're in a city centre, whether you're somewhere maybe more rural, that there is still plenty you can see right above your head with the naked eye.
Yeah, it was really nice, particularly going into Newcastle. We did a pop-up at Exhibition Park and we met maybe about 10 or so people there, but it was being able to show them that even from the centre of Newcastle, they could still see space. We were still able to show them the Andromeda Galaxy. We were still able to show them the Orion Nebula, things that they had never seen, especially not that close to home.
And the planets as well are visible too, of course, Mars, Jupiter, the two obvious ones. And I think a number of people I know just walking down the street, or friends I've been out with, they've been looking at a bright star and saying, what is that bright star? And they don't realise that bright star is Jupiter. Or what's that red star? And they don't realise that that's Mars. Little things like that actually they go, no, it's not. And it's just fairly simple in terms of astronomy, but it's just that quick wonder that people don't actually realise what it is that they're looking at.
Yeah, I mean, we always just say to people, it's amazing what you see when you actually do just look up. And I remember the first time I did it. I remember the first time that my mum, told me that you could see Jupiter in the sky, and she pointed to just a bright star, and I didn't believe her. And she didn't have a telescope to show me, so I sort of had to take her word for it. But it's still amazing.
And it is actually there. Looking ahead to February then, one of the things that, actually you can see it now in January, but it's going to peak in brightness. We have the comet in the night sky, which you can see, and it's going to get brighter and brighter and easier to see as we go into February. Handily titled Comet C/2022 E3 ZTF. As you were saying, it hasn't really got qualified for its own name so far, but that's it, and it is in the night sky. How do people go about looking for this?
So the way that I've been finding it over the last week is by checking Stellarium, actually, and figuring out where it is. It's been generally in the north, so it'll be generally towards the north, and it's just about naked eye visible at the moment, I think, but it is very faint. So if you're wanting to look for it, I would suggest using whatever astronomy app you prefer to use, whether it's Stellarium or Sky Guide, and trying to find where it is relative to bright constellations like the Plough or Ursa Minor. Just after dark for the next couple of weeks. So the sun's setting at the moment at around about 4:30 to 5. So by about 7 o'clock, 8 o'clock, we should have a decent level of darkness.
So there's your challenge for the month of February. See if you can see the comet and let us know how you get on. Of course, we have got some images of the comet in question on our social media pages. If you head to Facebook, you can see a time-lapse video, actually, of the comet making its way through the night sky as observed from Kielder Observatory recently. Our special guest in this episode, then, I'm delighted to say that we're joined by Dr Victoria Fawcett, who is a research associate at Newcastle University. She's an observational astronomer and has contributed to various projects such as the multi-object optical and near IR spectrograph, which is called the MOONs collaboration. And she's also been involved in the DESI collaboration as well, the Dark Energy Spectroscopic Instrument collaboration. That you might have seen in the news, actually, because they've put together the largest 3D map of the universe, which was a story in the news last year. But she joins us now. Welcome, Vicky. It must be a great time to be researching the distant galaxies, especially now with the James Webb Space Telescope up and operational and working, and giving you a real new insight into life in parts of space that previously we've never known anything about.
Yeah, definitely. It's I keep telling people when I do kind of outreach at schools that it's a really exciting time to be in astronomy at the moment, because we have the JWST where almost every day at the moment I feel like I'm seeing some new discovery. And Newcastle University actually is playing quite a big role in the JWST telescope. We have one of the astronomers, Dr. David Rosario. He's actually leading one of the first kind of scientific programs using JWST, looking for kind of outflows in what we call these active galaxies, so incredibly bright galaxies, and how this might shape galaxy evolution. And personally, something that I'm also involved in is the Dark Energy Spectroscopic Instrument, or DESI, and this is on a telescope in the Kitt Peak Observatory in Arizona, and this is going to look for kind of millions of galaxies and also about 3 million quasars, which are one of the brightest objects in the universe, and something that I'm particularly very interested in.
Yeah, you've done a lot of work with the quasars. Can you just explain to us what a quasar is for the benefit of those who are not entirely sure?
Yeah, definitely. So quasars are a very luminous, very bright type of galaxy where in the center we have a supermassive black hole. So this is a black hole that's kind of millions of times the mass of our sun. And then surrounding this supermassive black hole, we have material that's, because of the intense gravity of a black hole, is kind of whizzing around at immense speeds. And kind of the friction between all these like particles, this material going around this and falling into this black hole, creates a lot of heat, which creates a lot of light. So these galaxies have incredibly bright centers, so bright that the kind of nucleus often outshines the entire galaxy. So whereas like we know that our Milky Way galaxy, the galaxy that we're in, have these beautiful kind of spiral arms, whereas these quasars, they're so bright that you probably can't even see any of these kind of stars around, because the central kind of nucleus is so bright. And they're they're incredibly powerful and energetic, and we think that they might play quite an important role in the evolution of galaxies. So how we go from galaxy formation into the type of galaxies that we see in the local universe, like the Milky Way.
Yeah, and I know as well, or at least I've heard, so at the observatory, we've got lots of SDSS plates. We've got a couple of Sloan Digital Sky Survey plates. And I believe some of those sources are quasars, aren't they?
Yeah, so actually my PhD was predominantly based on Sloan Digital Sky Survey quasars. So SDSS is this huge kind of, it's surveying the sky and it picks up a lot of galaxies, but one of the kind of main thing that's it looking at is also quasars. So in the latest data release, so SDSS is still ongoing, but in the latest data release, there's 750,000 quasars. So it's an incredibly rich data set, which you can do, so much science with. So at the moment in astronomy, we have this ever-growing samples of objects, and so the science is becoming more data-driven rather than just kind of theory-driven.
And specifically, I was having a look on your website. I was sort of reading through very briefly your abstract for your thesis, and particularly you were looking at red and blue quasars. So with anything with space, obviously you've got these different wavelengths, these different colors then. So what do they mean in that context? What is blue? What is red? What are the differences between these two flavors?
Yeah, so I mentioned that quasars have this really bright disk kind of matter that's falling into this central black hole. So this disk is it's very blue. It peaks in optical to ultraviolet wavelengths. So when we look at quasars, they appear on the sky very blue. So in SDSS and a lot of other surveys, you actually select quasars as bright blue objects. So if there's this object that's quite far away, it's incredibly bright and it has a very blue color, we think, oh, it's probably going to be a quasar. But it's kind of what my research has shown, and it's based on other research kind of in the field, is that there's actually quite an important fraction of quasars that appear much redder. So this is optical wavelengths. And initially you would think, why is that exciting? Yes, okay, some appear red. But what we find is that these red ones seem to be a special population. So we think that they're red because there's some amount of dust in the system. So if you imagine a sunset, the sun's low down in the sky, so the light has to travel through more of the atmosphere, and this scatters blue light, so sunsets appear red. And we think it's kind of a similar thing going on in these quasars, that there's some amount of dust that's scattering the blue light and they appear red, sorry. But more than that, if you look at radio, so look at other wavelengths, we find that they have peculiar radio properties compared to the blue ones. And we're still actually trying to understand why that is, kind of what is the connection between the red and the blue quasars. And what we're finding is that these red quasars might be an important kind of transitional phase in the evolution of quasars. So potentially a red quasar has this dust, has this interesting radio emission, and then through winds or jets, you then blow out all of the dust and you reveal this typical blue quasar. And the fact that kind of transition period, we think, is quite relatively short-lived in terms of the kind of the lifetime of a typical quasar, and that's why we find that the majority are blue. So yeah, the red ones we think are a very interesting population, and it's what I've kind of dedicated my PhD, and I'm still looking at now at Newcastle University as well.
And you are involved in some of these collaborations with various scientists from around the world, and these are quite big collaborations as well, such as the Moons project and the DESI collaboration as well. Tell us a little bit more about the work that you're doing there.
Yeah, so I mentioned DESI, so that this my PhD was mainly based on SDSS, where I used in my work, kind of 500,000 quasars and kind of looked at red quasars in SDSS. But with DESI, we're going to get 3 million quasars at the end of the 5-year survey. So DESI will finish about 2026. And DESI's pushing to much more fainter and much more redder systems. So what we're going to do is trying to extend our work using SDSS, kind of moderately reddened quasars, to DESI, much more heavily reddened quasars. And within DESI, I have kind of an observing program that is actually trying to target specifically these reddened quasars, because they are quite rare. So we need to target them to boost the numbers. So, and in my work that's not published yet, but we're finding a very interesting link, a direct link between the amount of dust in a red quasar and kind of the strength of the radio emission. So there's definitely this interesting link between the production of radio emission and the dust. And then looking towards the future, I'm now kind of, as part of my my role at Newcastle University, we're involved in what's called moons. So this is I'm going to try and see if I remember, the multi-object optical to near-infrared spectrograph. So this is similar to how kind of SDSS works, but SDSS was in the optical and moons is going to be in the infrared. And it's going to be a new instrument on the Very Large Telescope, and is going to, again, look at these quasars, these active galaxies, but now pushing towards the infrared, where we can kind of do, different kinds of science. And moons should be on sky, I think, start of 2024, let's hope. And so I'm currently working within the kind of technical team to help make sure that's all up and running when it starts taking data.
Obviously, DESI and Moons, they're both two very big projects that are going to have a massive impact on the work you can do. If you were given a blank check and unlimited funds, what would you do with it? Like, what would you design? What would you build? What would you want to investigate?
I guess an easy one would just have it be, to have JWST observe, thousands of red quasars. That would be really interesting to kind of constrain. JWST can look at the mid-infrared, and we can constrain actually the dust properties and understand more about the nature of dust. Equally, I would quite like, similar to JWST, but the Hubble Space Telescope that's still taking amazing data. I would love to take amazing HST images of red and blue quasars, and with that you can compare the host galaxy morphology. So we predict that if red quasars are in this transitional phase, that they might, and if this evolutionary scenario starts with kind of two merging galaxies, you might expect the host galaxy of a red quasar to be more disturbed than a blue quasar. And there's some studies that have looked at 8 red quasars, and they found that this might be the case, but because it's quite difficult to get HST time. But if we could have 100 red quasars and 100 blue quasars and compare them, it would be great to actually have these amazing images of the actual host galaxy that these quasars are in.
Ishbel is another of our science communicators at Kielder Observatory. Ishbel, you've been on the sidelines so far. Have you got any questions you'd like to ask?
How did you get into quasars? Because they do seem to be rather your entire life now. Your whole research working life is these quasars and these red and blue quasars. How did you get into that how did you get into astronomy as well, just for interested younger listeners? What drove you to get into this?
I know some astronomers, they say from the moment they, from as far back as they can remember, they were in love with astronomy. But for me, it was more of a kind of, I wasn't really sure what I wanted to do when I was younger. And I remember at school, I enjoyed maths and I was good at maths. So, and that's kind of all I knew. I wanted to be a singer, then an artist, then a vet, and then, I wasn't really sure, but I knew I liked maths. So kind of for A-levels, I took maths, and I also took some of the sciences. And I was pretty sad, actually, that I wanted to do maths at university. And it was really during my A-levels that I had, amazing physics teachers. And it was the first time I'd actually thought, oh, physics is actually quite good fun. So when I went to university, I did maths and physics, still, wasn't entirely sure what I wanted to do. And it was really during kind of university, kind of exploring different topics, topics that you didn't really get to explore much at school. And physics was really interesting. I just knew particle physics and astronomy I found very interesting. So I did a project in exoplanets, actually. So I did a year studying exoplanets, and I decided this is great. Astronomy and research, this is definitely what I want to do. But I just wasn't. I'm sorry for all the people that I do love exoplanets, but I just decided it wasn't for me. It's not what I wanted to do for the rest of my life. But I knew research in astronomy was something I was really interested in. And it was just from a course that I took, and we were learning about these quasars, and they were incredibly powerful, the brightest objects in the universe. And I just remember thinking, these are really interesting, and kind of read up a bit about them online, decided, yeah, this is something that I think I'm really interested in, and applied for PhDs in the subject. And, I wasn't even sure whether I'd enjoy the PhD, but I really enjoyed the research environment. I enjoyed quasars so much so that I've decided, kind of that's what I want to do. And I'm still doing quasars and active galaxies now in my kind of later job as well. But yeah, so it wasn't really a set straight path that I think a lot of children especially worry that they don't know what they want to do. But I think just, take the subjects you're interested in, and then it works out. So it worked out for me.
Yeah, exoplanets weren't my favourite either.
They were right, but quasars are more exciting, I think.
So then, now that we've spoken about a bit about your past in physics, I just want to ask, what do you see as next for you? Is it still hoping to... What is more of the academic track that you're hoping for now, or is it working on these Moon and DESI? And
so, yeah, I've only recently started this position in Newcastle, so I've got a few years here, and I think kind of my main projects that I'm working on is DESI, because this runs, I'm still part of DESI, and this will run until 2026, and we're just going to have this ever-growing amazing sample of these quasars. And then Moon starts, either end of this year or in 2024, and I'm going to take, an active role in this, this collaboration. It's more of a kind of European collaboration. And then alongside that, I have a couple of other projects. So I've got more radio data, because something I've been interested in is this radio dust connection. So three years ago, I went to India to take some radio observations with the Giant Meter Radio Telescope, so GMRT, and that's in Pune in India. And actually in February this year, so almost exactly 3 years later, I'm going to go back to India, back to Pune, to kind of learn more about this type of radio data. And from this, we can maybe understand a bit more about the nature of radio emission in these red quasars. But yeah, the future for me, how I see it right now is that I would love to continue in academia. I feel like I get paid to do what I enjoy every day, and you can't ask for more than that in life, I guess.
You do get to visit all sorts of weird and wonderful parts of the world. The fact that the large telescopes in the world are in such sort of remote locations gets you to some fairly unusual places, and it must really broaden your horizons about the world that we live in, and seeing how other cultures operate and their approach to sciences as well.
Yeah, it's something that one of the things I really love about astronomy, and I've got to say, being an observational astronomer, you do get the benefit of travel. So you have all these telescopes in amazing locations that you get to, visit and take the data, although, more of these telescopes are moving towards, a more fully automated process, but it's still good to, visit them and understand. It's good for astronomers to know how the telescopes work instead of just taking the data kind of blindly. And then also because you have, these days, astronomy is such a kind of international community. Back in the day, it would just be a team of one or two, or just your institute. But for example, DESI is worldwide. There's institutions from all over the world, and then you have the ESO, the European Southern Observatory, and all these collaborations that mean that you get to go to conferences and different locations. You get to meet your collaborators, and it's something that I've really enjoyed. So I've met people from all over the world, and it's just really great to, hear about different people's backgrounds and cultures, and have friends. I mean, it's good and bad. I now have friends that are all over the world, so they're quite difficult to visit, but it is nice having this big kind of international community.
And have you noticed any, or have you learned of any, obviously being an observational astronomer, any sort of different theories about how they look at the night sky? Because some parts of the world, in a previous episode we were talking about this, that different cultures, maybe particularly those in far places, say in the Pacific and so on, they have real theories about the night sky, real stories about how the stars and the constellations found their way there. Do you pick those kind of things up as well?
So I have heard of kind of the different. I have also been interested in the historical astronomy, where different communities looked up in the sky, and the constellations that we know and love are just the ones that we've looked into the sky and decided what they look like. But different communities, depending on their culture, looked in the sky and saw different kind of connections of stars. And so there's different constellations depending on where you are or how far back in time you're looking. So yeah, it's definitely something interesting. And I guess in my work, it's a well-known fact that if you have people, a broad range of people, then you have so many different ideas because of the way, everyone thinks differently. So if you have a group of people that are all very similar, you're going to have just quite a single track way of thinking. Whereas if you have this big kind of boiling pot of different communities and backgrounds and cultures, it means that you have a much more vibrant way of thinking and doing science. And I think that's one of the areas that science has really progressed, is that we'd be much more inclusive in terms of getting people together.
And tell us about your award as well, because you got a special recognition award, a STEM award last year, didn't you? Tell us about that, because that's obviously in recognition of the work that you've put in, your own time and your dedication to the subject.
Yeah, so alongside the research, that's what I do every day, and I love it. But something I am also really kind of invested in is outreach. So kind of bringing science to the community, and in particular, the area that I really like to work on is doing outreach in schools. So it's something close to my heart, that there's still, unfortunately, it's getting better, but fewer girls take STEM subjects. And it's not just that there's fewer girls doing STEM at school, which then trickles down. At every stage you see girls dropping out, basically. So even though you have maybe a healthy percentage of women doing physics at undergrad, you then see fewer, a lower percentage then that carry it on to PhD. And a lot of people have been looking into kind of why there's this, it's called the kind of leaky pipeline. Why do women predominantly keep dropping out at every stage? And, it's partly to do with the culture, and partly to do with a lot of women just thinking physics is not for them. And I remember being at school, and I'm very lucky that I had a mum that was a maths teacher. So it never really occurred to me that women couldn't do maths, because I had my mum as a role model. And I wanted to be like her. I wanted to be good at maths. But a lot of girls don't have that, and a lot of the environment in school and friends and family say, oh, you don't want to do physics, that's for boys. So by going to schools, giving talks and just showing that you can have successful women in STEM, in physics, I think just having the presence of a female astronomer, it might mean quite a lot to children, that they see, oh, look, you can be a woman and be an astronomer. It's not this far-fetched idea. So, yeah, so the kind of award that I won was in recognition of a lot of outreach I do within schools, predominantly in the northeast of England, where I've been living for the last 5 years now. So, yeah, just raising awareness about how great astronomy is, but STEM is a wider subject, is to pursue to children.
And it is inspirational, actually, just seeing a person, whoever it is from whatever walk of life, that you can be that person and you can achieve your goals, whether that's to be an astronaut, or whether that's to be a newsreader or a politician, or whatever that child is interested in. When they see someone who maybe is from a similar background or the same gender or whatever, even same hair colour sometimes, can make a big difference to see that person standing there, and it really does inspire them to sort of prove that whatever it is that they want to do, that it is doable.
Yeah, you'll be surprised that when people are confused why women don't do physics and STEM, they're like, well, we're at school we never said, oh, girls can't do this, but it's just these like small kind of messages that children get from a really young age. So I remember something stupid like I wanted some kind of star print bedding when I was a child. And, things have got better. But back when I was, very young, I remember that you have the girls section and the boys section for like bedding and clothes. And the boys section has the rockets, astronauts, stars. And the girls section has pink, rainbows, unicorns. So just being a child and seeing all the astronomy things under the boys section, that's a message enough that you get from a very, very young age to say, oh, well, that's for boys, like I should be liking this stuff over here. So it's little kind of societal things like that we still have a long way to kind of overcome that, and to not have all the space things in the boys section.
When I was picking my subjects for A-level and for university, I studied maths and physics as well. But a big part of why I studied maths and physics from A-level onwards was actually because people told me that I shouldn't. And it was sort of a way to defy expectations and push back against what people were telling me I should do.
Yeah, so I think a lot of my friends similarly had to overcome barriers. And it's great having when you're at university, but in my opinion you kind of you've had to overcome those barriers by that point. So it's why I think targeting schools is really important, because there'll be people that didn't overcome those barriers and so aren't at university. So it's trying to make sure children are aware, that make it easier, like so that they don't have to overcome barriers to go to university to study STEM, and to show them that it's an exciting subject and it is for everyone. And I mean, personally, just in the last the last 5 years, actually, I have seen I've already seen a lot of change, which is really nice. I've seen it's a lot more, the environment's a lot more inclusive. I've seen the gender ratio getting a lot better, but yes, we do still have quite a long way to go, unfortunately.
Yeah. My story is a little bit different. I was actually inspired by Barbie to get into astronomy.
Okay.
Because Barbie Swan Lake starts off with finding Cygnus in the night sky, to then lead into the story of Swan Lake and this girl that saves a forest with bravery and all that. And I really took the wrong moral message from that movie. And instead of being like, yeah, I can be a princess and save a forest, I thought, dot to dot in the sky, that's cool. And then the CD-ROM game, it had constellation finding in it. And that's how I got into it, because there just was that small game that you could play that was on Barbie. And so I thought, yeah, this must be for girls, finding things in the night sky. And yeah, because of that, I ended up getting into stargazing, knew some constellations, and then I felt clever because nobody else knew what they were, so I could point stuff out, like, to my parents late, well, not that late at night. You can't tell from the very thick Scottish accent. I'm from up north, and it gets very dark very early there, so even coming home from school, the stars are out! At least in winter. So I was able to get into it that way and felt like it was a small little hobby that I was able to have just because it came from Barbie, so clearly that's definitely girly. And then I never really got much pushback until I got a little bit older. And it was more like, yeah, I'll be a baker. Sure, that sounds better.
Yeah, I think it's important to provide links. So growing up, I was always very creative and very into art, and I always figured that's what I would do until I decided that I wanted to do maths and physics instead. But it wasn't until I got to university, I'd say, that I really started to understand the creativity that underlies STEM and the fact that art can go a long way to helping within STEM in terms of like, if you're thinking in this creative artistic manner, that is often a very good framework of thought to put over any sort of science questions. And I know that in my own outreach with schools, or whenever we've gone into schools with the observatory, when I've talked to young girls, when I've talked to young boys as well, they always, they sort of see science as the antithesis of creativity, and being able to prove that wrong or being able to show them how that's wrong, I found has been a really great way to connect with them.
Yeah, no, it's a really good point. And I have a kind of similar background, that I was really into art and music, and I almost took art and music as A level, and then but by that point I was pretty set on that I wanted to go down the science route. But I guess I also as a student at school thought them as quite separate. It's like, oh, I either go down the art route or I go down the science route. But science is incredibly creative. It's you're kind of you're exploring things, and you're thinking about these big ideas, and you're then creating these plots, these figures, papers. So I think there's a reason why that they find there's a strong link between people that enjoy music and people that enjoy science. There's quite a big link, and I think people at school might not realize that, because the way that maths, for example, is taught at school is that you just learn a set of formula, and you just solve these equations. But when you get to undergrad, it's a lot more kind of exploring and thinking and creativity. So there's huge overlap that I think is maybe just not clear when you're at school, but they're equally important in research.
Well, I've got one more question. It's another sort of general question, not particularly about your work necessarily, but it's another question that I like to ask people who work within space, which is, would you go to space if you got the opportunity?
I get this one a lot, and my answer is definitely yes. And I know a lot of astronomers that really don't want to, but I would jump at the chance to go into space. Not necessarily, it doesn't have to be too far, but I would love to just be able to just go and have an orbit around the Earth and see the Earth from space. I would think that's amazing, and if I ever had the sort of money that it takes at the moment to go into space, I would jump at the chance. Yeah, I'd love it.
I think we're very torn at the observatory amongst the team about who would and wouldn't go to space. And I don't know about you, Ishbel, but I'm definitely on the would go side.
Yeah, I would go 100%. I'm just slightly not allowed to because of my eyesight. And I have type 1 diabetes now. When I got that was like one of the main things. I was really upset when I got diagnosed, because I was like, well, now I can never be an astronaut.
Well, never say never.
Which is not one of the things you usually think about when you're in the hospital, but,
Well, never say never. You never know. One final question then for you, Vicky, and that would be to the future. You're all about the research, but we've got more instruments now that are getting more and more information than ever before in the field that you're interested in, these galaxies, deep galaxies, and the origins of the universe, really, I guess you'd say, with the James Webb Space Telescope being that example. Where do you think we will be in our knowledge of the formation of galaxies and the formation of the universe even in say, 10 years from now? What do you hope that we might know?
For my work, I guess in particular, I would hope in 10 years we'd have a really good understanding on how galaxies evolve. So the lifetime of a galaxy, what happens, what phases do they go through? And also, how does the kind of energetic supermassive black hole, so we know that it launches kind of jets and winds, a really big question is how do these jets and winds affect the surrounding host galaxy, which is something called feedbacks. So how does it affect the number of stars produced? Does it increase it, decrease it? Does it not do anything? That's still a very kind of talked about topic at the moment. So hopefully in 10 years time, we'd have, through, not just observations, that there's also these, big simulations that are improving every year. So I think the kind of connection between these simulations and the number of observations we're going to get, I think the next 10 years is going to be incredibly fruitful for astronomy and, understanding how galaxies evolve over time.
Dr Victoria Fawcett, thank you very much for joining us on the Kielder Observatory podcast. And if you'd like to find out more, then you can find Victoria online on Twitter, astro_Fawcett, and on LinkedIn as well. And you can find links there to her own website as well, which has got more info about the things that she's worked on in the past and working on at the moment. Dr Victoria Fawcett, our guest on this month's episode of the Kielder Observatory podcast. Just before we go, just to wrap up, just to say, if you'd like to come and visit the observatory, well, you can book ahead right now for pretty much, I think, the year ahead online at kielderobservatory.org. So get yourself on there, have a look at the sessions that are available. There's plenty of them across the rest of the year, really, and find a date that works for you. Get in there, book your time, and then we can look forward to seeing you. And you might well get to meet Ellie and Ishbel, who have been joining us in this episode as well. And I guess that the Aurora sessions remain popular, don't they? There's a good chance sometimes of seeing the Aurora. We have had the Aurora make an appearance at Kielder as well, and they're usually the popular ones, but there's many more topics available.
Yeah, the Aurora still remains our sort of most popular event, and it's been a good year for it, to be fair. We've seen a lot more Aurora than normal this year. And
there was the one time, these sessions for the Aurora are about the Aurora rather than a guarantee for you to see it, but it did actually arrive in an Aurora session.
Yes, so particularly around September and October, yeah.
Get online and book your visit to the Kielder Observatory and join us next month for our next episode of the Kielder Observatory podcast. We've got plenty of guests on the way, including focus on the Aurora, actually, to learn more about that in one of the coming episodes. So look out for that on all good podcast apps, and we'll join you next month on the Kielder Observatory podcast.